Alright, so here we go. One of the things that could go wrong sometimes with the partial fraction decompositions, not necessarily that it goes wrong, but one of the things you should be cautious about is that often you start off with an example or an integral where the top is a higher degree than the bottom, higher or equal. When that happens, you're better off doing long division to reduce the numerator first, to reduce the remainder to the top, so that the top should be of degree smaller than the bottom. Not equal or larger, but it should be smaller. Again, the perfect remedy for that situation, long division. And it could go something like this. You could do long division any way you like to. Most people were probably doing something like this when they were in that class. X squared minus x, how many times will it go into x to the 5? Well, some of you may need placeholders. X to the 4th plus 0x to the 3rd plus 0x squared plus 0x plus 0. So they're just placeholders. X to the 3rd would give you x to the 5 minus x to the 4th. Subtract them, that would give you x to the 4th plus 0x to the 3rd. Start the process all over again. X squared would give you x to the 4th minus x to the 3rd. Subtract them. X to the 3rd plus 0x squared. That would give you x, so x to the 3rd minus x squared. Subtract them. That would give you x squared plus 0. And I could go one more time. I would give you x squared minus x, subtract them, and that would give you x. And that's the remainder, x over x squared minus 1, minus x. And so you could take your integral, and now you could write it this way. You could say the integral, the integral of x to the 5, well, here you could do it this way. X to the 5 over x times x minus 1 is really equal to x to the 3rd plus x squared plus x plus 1 plus x over x squared minus x. That's based on long division, right? Like that. That's based on long division. And now the punchline is that, of course, if you were going to integrate this with respect to x, that would be the same thing as integrating this with respect to x, 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 and integrating this with respect to x. Each of these should be easier than the original one. Of course, this is just power rule, x to the 3rd, x squared. These are all super easy. Really, the only one you have to deal with would be the very, very last one. Okay, on the last piece, you could try partial fraction decomposition, or better yet, one of the other things that could go wrong is if you haven't really simplified your fraction yet. That wouldn't be good. X over x times x minus 1. I reckon we can simplify that. We would just cancel the x out of there, make it a 1. And that would leave us with 1 over x minus 1. So really, the last one was the whole problem was equal to all that stuff plus the integral of 1 over x minus 1 dx, which is a piece of cake. So the final answer would be x to the 4 over 4 plus x to the 3 over 3. I'm working out of this piece. And that would be x squared over 2 plus x, that's that piece, plus ln of x minus 1 plus c. There you go. We did it. What was the moral of the story? A couple of things. Make sure you got a proper fraction. If the top is bigger or equal, do long division. By bigger or equal, we mean the degree. Do long division. Hopefully it gets you a bunch of simpler, easier problems. Second lesson, you should simplify these fractions whenever you can to make sure you've killed all the common factors. Then everything works out nicely. Sometimes. Most of the time. Alright, let's try to take another example. There are other things that could go wrong or not wrong, but they could add some nuances to the procedure that we should talk about.